All right. How we doing, grade nines? I missed you. I wish I were there with you, but I'm not. I'm right next door at a math meeting. I'm learning all about teaching math, which I'm quite excited about, but I do wish that I were not away from you guys, but that's okay. So today, we're going to look at something called bioaccumulation, right? And it also relates to these other terms: bioaccumulation, bioamplification, biomagnification. They're all kind of 6 of one, half dozen of the other, different names for the same basic concept. So what we're talking about today is this. Bio, of course, well, we know what that means. That means living things. And then what does it mean to accumulate something? Now, maybe you, well, I don't know, maybe you have a room that accumulates junk or mess or dust or dirt, but it means to gather over time. Talk about living things that gather something over time. And this is where we're going to get kind of into the environmental portion of this course. So nutrients are something we've talked about. Nutrients like carbon in the carbon cycle, or nitrogen in the nitrogen cycle, or water, or all those things. Nutrients are kind of simple compounds, the simple stuff. And they are designed to be used by us. So we eat them, we absorb them, we get them in some way, we use them. And when we're done using them, and then we recycle them, we get rid of them. So any of the nutrients that come in our body are used by us, but then they're broken down and they're recycled. We get rid of them. On the other hand, not everything's like that. Pesticides are an example of what we're going to talk about today. These are more complex compounds. And a pesticide, what we're talking about today, is a compound designed to not break down. Right? It is designed not to break down. In fact, its job is the opposite. Its job is to stay inside of a pest and to kill it. Right? Probably you've heard of pesticides before. But anytime you see this ending side, it means to kill. For example, suicide is an awful word. It means somebody killing themselves. But homicide, homme is the French word for man. So if you kill a man, you've committed homicide. Don't do that. So no, if you kill a man who is the king, if you kill the king, you've committed regicide. And there's lots of other examples. So side is a suffix meaning to kill something. So when we're talking about pesticides, it literally means killing pests, killing things we don't want. And usually this applies to a farmer. It's mostly farmers who use pesticides. So if you're a farmer, you, for example, might use an insecticide to kill, yeah, you got it, insects. And, there's lots of examples, but I'm going to put one here, DDT, which is a famous insecticide that we used to spray all over apple crops and pear crops so that we could be sure that, no bugs would get on them and chew on the skins and put little marks on the skins. And we'll talk about DDT later because, it was later shown or demonstrated to be dangerous and it was restricted in its use. So insecticides kill insects. Well, what about a herbicide or an herbicide? Well, you grow herbs in your garden. Herbs are plants. All right, so a herbicide is used to kill plants. You might think, well, wait a minute, but a farmer grows plants. But think about your lawn. Maybe I don't spray my lawn. I believe in biodiversity, and I think the lawn looks just fine if there's some kind of weird things, some strange weeds growing it and things like that. But you may have gone by lawns and seen, the little sign that says like, "Weed man has sprayed this lawn. Stay off," because sometimes we want to have just one plant somewhere, and we want to kill all the other plants. An example of that is a product called Roundup. A lot of farmers use crops that are Roundup ready, which means that the crop won't be killed by this herbicide Roundup. But in theory, all the weeds that we don't want, all the nonsense that we aren't going to grow and eat, the Roundup will kill. So they can plant a whole field and then spray this Roundup, and it will kill everything but the plant they want. So that's an herbicide. A fungicide, of course, kills fungus. I'm just going to put an example of something here called Captan, which is just one example, but there we go. And then a bactericide. Now, in medical terms, we usually call this just an antibiotic. But a more specific term for it is actually a bactericide, and it, of course, kills bacteria. An example of this would be penicillin. Penicillin is a pill that you can take, and it kills bacteria. When penicillin was first discovered, which is something we might get a chance to talk about a little later, it really changed the whole world, because for the first time we could kill bacteria inside our body. And so for somebody who just had surgery, or for somebody who was quite sick with a bacterial infection, this could be life-saving, because this is a kind of pesticide. It kills something that we don't want in our body. But what we always have to remember is that a lot of pesticides, not all of them, mind you, but a lot of pesticides are designed, remember, to not break down. Right? So a lot of pesticides are designed to stay in the body. And these, over time, build up in the bodies of organisms. And when they do that, they're going to do something. They're going to move up the food chain. They're going to move up the food chain. Because if they don't break down, and they're in the plant, well, when the animal eats that plant, they're going to get that pesticide. And then if another animal eats that animal, if the pesticide isn't broken down, now it's going to go into that animal. And so these move their way up the food chain. And we call this process bioaccumulation. Bioaccumulation. And at each step on the food chain, which I hopefully remember, levels, remember that from the ecosystems assignment I had you do, the different trophic levels. First trophic level eats the plant, second trophic level eats that animal, so on and so forth. At each step, at each trophic level, how much pesticide is in the animal is just going to increase and increase. We're going to show why in just a minute. And this is a process, so that should say increase. And this is a process we call bioamplification. Just another word meaning the same basic thing. The idea that up. They build up higher and higher. So let's talk about this. I want to imagine I've drawn a little very crummy, well, I didn't draw it, pardon me. This note is somebody else's work. But a teacher has drawn a very simple diagram here. And at the bottom we have Just grass. Good old-fashioned grass. Well, what eats grass? Well, one thing that eats grass is the grasshopper. So you could have a grasshopper in the grass, it's eating it. And then we could have little shrews, you know, these kind of rodent-like animals. They could come and they could eat the grasshoppers. And then what's going to eat the shrew? Well, an owl might eat the shrew. All right, and that could be our food chain. But now here's what I want you to imagine. I want you to imagine that I have said, well, wait a minute. I want my grass to have no weeds in it whatsoever. I want it to look beautiful, absolutely beautiful. So I take my grass and I spray pesticides all over it. Now, every little blade of grass just has like a little tiny bit of pesticide on it. But what's going to happen is the grasshoppers eat grass, and they eat, you know, a fair amount of it. And so all of a sudden, before you know it, every grasshopper's got a little bit of pesticide inside of it. And maybe this pesticide doesn't kill the grasshopper, but it doesn't break down, so it's in its body. Well, now, let's imagine that this shrew eats 4 grasshoppers. Well, now, how much pesticide's inside the shrew? Well, it's got all of that pesticide. It's got the pesticide from all 4 grasshoppers in it. And that's if it only ate 4. You know, we're just going to imagine like one day where the shrew goes around, you know, the same day that we've sprayed the pesticide, the shrew goes around and eats the grasshoppers who've eaten the grass, and now it's got 4 times as much pesticide inside of it as each of the grasshoppers had. And you can imagine, if this shrew stuck around for weeks, it would have way, 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 way more pesticide in it than any one of the grasshoppers did. But we're just talking one day here. Then let's imagine that Mr. Owl comes along. Mr. Owl's hungry. But he's really hungry, so he doesn't just eat 1. Maybe over the course of bedtime, he eats 3 shrews. Well, now, Mr. Owl has got the 4 from this shrew, and the 4 from that shrew, and the 4 from that shrew. And so what we end up is that the grass actually had just a little bit of pesticide on it. You look over here, the grass didn't have much pesticide. Yeah, we sprayed it all over, but each individual blade of grass, not much pesticide. But as the grasshopper eats more and more grass, the grasshoppers actually end up with more pesticide. And then those shrews that eat the grasshoppers, well, because they're eating a bunch of grasshoppers, they get pesticide. And then what ends up with the most pesticide of all? The owl up top. And so here's the idea. As we move up the food chain, more concentrated pesticide. Well, that is an E and a D together. Just like that. So as we move up the food chain, we get more and more of these kinds of products there. And this comes up in all kinds of ways. We're going to talk over the next little bit, but we have to be careful. When we eat animals that are high on the food chain, we have to worry about what they've accumulated. And it isn't just necessarily pesticides. We have to be careful eating a lot of tuna or a lot of big fish, because they can have built up. They can have, through bioaccumulation, have gotten a lot of mercury and heavy metals and things like that built up in them. And if we eat too much, we have to be careful. Same with eating some of the fish in northern Ontario, where there's paper mills, there's products there that accumulate in the big fish that we have to be careful eating. So specifically, we're going to take a few minutes and you're going to read this, a case study, the Book of the Dead, A Farewell to Wales. All right, you're going to read this. You don't have to write this. Read on your own. And I want you to discuss and answer these questions with the person next to you, all right, with your desk mate, all right, with the person whom you share a desk with. And then you're going to take this up as a class. We're going to talk about the back page. Please. You're going to pick 2 of these questions and answer them. All right, you're going to pick 2 of the questions. And then you're going to answer all the thinking questions. All right, and I'm going to look at that tomorrow and make sure you've done that. So in class, first we're going to read this case study about Wales, and then the back is going to be for homework for you. So thank you guys again. Oh, goodness. So thank you. Work hard on that, and I will see you tomorrow. Have a wonderful day. Bye-bye.